Hello and welcome to Network with Louis. So in today's video, as a continuation to our ACL series, we'll be configuring standard ACL and extended ACL. So like we know, the standard ACL is the basic form of ACL and it has limited options as to what we could do, whereas the extended ACL gives us a more granular control as to what we can do. So we have a lot of options. We could deny traffic based on hosts, based on network, based on routing protocols, and some other protocols. All right. So ACL generally, it's a rule. I like to call it a security mechanism in networking that enables us to control and filter the flow of traffic in and out of our network. All right. So knowing what we know, and in the last video you saw that all the devices in this topology could ping themselves. So for instance, PC8 could ping, this is PC8 IP 4.0.0.2, PC8 could ping 1.0.0.2, which is PC0's IP, and I could try to deny that pinging from happening. As you can see, it's pinging successfully. Using ACL, I can deny this. I can isolate PC8 in such a way that whereas these other PCs can ping, this PC0, only PC8 would not be able to ping. And how do we do that? We do that using access list. All right. So I'll be showing you the two forms of access list in this video, and in subsequent videos still on this ACL series, I'll be showing you the other forms of access list. All right, so let's begin. We want to treat the standard access list first, but before we go into the configuration, there are things I want you to know. So when we are talking of access list and when we want to configure the standard access list, for instance, there are key things we need to know. The first, you configure the standard access list closest to the destination. We configured closest to the destination. The other point which we need to know is that standard access lists are numbers ranging from 1 to 99. So when you impute your access list ID, a number within this range, automatically Cisco devices know that you are trying to configure a standard access list, and by doing so, they conform the settings to that of the standard access list. I'm going to show you all of this right in the configuration process. Another thing you need to know, or this is a rule also, but it is not written on stone, but it's more of a best practice. You start your rule by putting your deny rules first at the topmost. Reason being that access list goes from up to bottom. The rules are read from line top to bottom. So if you don't place your deny rule appropriately where it should be, you might be permitting a traffic whereas you intended for that traffic to be denied and you would not get the desired result. So it's a standard practice to always put your deny rule at the top first before any of your permit rule. Like I said earlier on, this is not written on stone. Depending on your environment and your scenario, your permit rule might come first. Okay, having said all of this, let's go into the configurations proper. Now, to configure a standard access list, I will just go to the router. By the way, we configure access list on the layer 3 because it's a layer 3 function. So we go into the router and enable configure terminal. All right. So to configure a standard access list, we use the Cisco command access list. Then we specify a number from 1 to 99, which is within the standard access list range. So I want to use 5, for example. Then I'm going to do deny. It starts with the deny rules. So I'm going to deny. Then I'm going to specify either a host, a network, or an entire subnet. So if I use the question mark, you see it shows us if it's a host, a network block, or any. So in this case, because I want to deny only this host, only PC8, I'm going to use host because it's a host. But if I wanted to deny the entire 4.0 network, I'm going to use the first option, which will deny this. All right. So I'm going to use host. Then I'm going to specify PC8's IP address. So PC8's IP is 4.0.0.2. 4.0.0.2. Then I hit enter. I've denied it. Now, I also need to add a permit rule because in as much as I want to deny this, I also need to allow every other thing to be working as they should. So I'm going to add a permit rule using the same access list 5 permit in. I'm going to save. Now, I also want to state and make it clear that an access list does not take full shape or does not come into play if it is not applied on an interface. So, because I did this, doesn't mean the access list has started working. If you notice, if I try to ping from PC8 to that IP, I can still ping it. It's still pinging successfully because I only configure the access list on the global configuration mode. I haven't applied it on an interface. So this is where we need to apply it on the interface, and that is where the rule which says we apply standard access list closest to the destination comes in, right? So looking at this, we know this is the source and this is the destination. So between this and this, which is closest to the destination, we know this is it, right? So we're going to apply it on this interface. So we go into that interface, gigabit 0/1. So interface G0/1/0. Then we'll do IP access group. Then we'll specify the access list number, which is 5 in this case. Then we'll specify if it is either in or out. If I use the question mark, you will see inbound or outbound. Now, what informs the inbound or outbound nature of the traffic is the origin, where it starts from. So for example, I want to move this way to the destination. From here, it is an inbound movement, right? So from here, it's an inbound movement, but from here, it's an exit. So it's an outbound movement. Then into this router, this is an inbound movement. Then exiting from this router is an outbound movement. So we will apply it on the outbound because this is an outbound interface, right? So going back into the router, we apply it on out and enter. We save, and with this, we should be able to deny this PC from pinging. You see, it is now showing destination host unreachable. Mind you, we denied this host entirely. Let's go back to the access list and we would see. So for example, if I do show run, exit from here, do show run, and I'm going to filter using access list, begin with access list. Now take a look at this. I denied the host. What this means is this host has been isolated from the entire topology. It would not be able to ping any other PC. I did not just isolate it from pinging the 1.0 network, I also denied it from pinging the entire PCs in this topology. So for example, if I wanted to reach my server, which is 3.0.0.2, from that same PC in 3.0.0.2, you will see it is showing destination host unreachable. I am unable to reach any device because this is a standard access list. It is very, very restricted in terms of option. Also, if I want to reach 2.0.0.2 from that PC, ping 2.0.0.2, you see it is unreachable. So this goes to say that PC8, for example, has been isolated from the rest of the network, whereas PC7 can ping everything as issue. So if I want to ping 2.0.0.2, so it's pinging successfully. I'm going to ping 3.0.0.2. Pinging successfully. If I want to ping 1.0.0.2, pinging successfully. So every other PC could ping, whereas PC8 has been isolated, so it can no longer ping. That is what the standard access list does. Very limited. I have very minute option. Let me also show you. Going back to the configuration, when I used the question mark to see what I could do, you would see that I have very limited option as to what I could do. I could either deny the entire IP, subnet, or network. I could deny any, and I could deny host. These are just the three options I have using the standard access list. Right. So now I'm going to show you how to configure the extended access list. So let me use this 1.0.0 network to demonstrate the extended access list. So for example, I want to ping from PC2. I want to ping PC7. PC7's IP is 4.0.0.3. So ping 4.0.0.3. And you see I can ping, but I want to deny this ping from happening. All right. I don't want this to, I want to isolate PC2 from this entire network. I don't want it to be able to ping this PC7, but I want it to be able to ping other devices. So for now, you see it can ping PC7. Let me also try if it can ping the server. Server is 3.0.0.2, so ping 3.0.0.2, and I can ping the server. So I'm going to use an extended access list to deny this PC from pinging this PC. All right. So to do so, like we mentioned earlier, access list is applied on the layer 3. So I'll go to the layer 3 of that PC. So which is the router R0 in this case. And I'm going to enable configure terminal. So to configure access lists, extended access lists, I also need to point out some key things that should be known. So you want to configure extended access lists. First, it is worthy to note that an extended access list number ranges from 100 to 199, and from 2000 to 2699. All right. Another key thing we need to know about extended access list is that it should be applied closest to the source. All right. And another thing, we need to all begin with our deny rule, as in the case of the standard, because there exists what we call an implicit deny at the end of every access list. It exists at the bottom of every access list. So let me quickly do a quick maths to demonstrate this, because some of my students often ask this question: what do you mean by the implicit deny, and what is the use of implicit deny in access list? So for the sake of clarity, I need to use this mathematics algorithm. So the reason why you need to begin with your deny, let me use the minus sign to denote deny. So equals to minus, and let me use permit equals to plus. Equals to plus, right? So this is a rule. Now, after you've done your deny rule, after you've put in your deny rule in your access list, you need to use permit any or permit any. Permit any. Because there is an implicit deny at the bottom. That's the last rule on every access list. So this permit any would cancel out the implicit deny, because the permits signify positive and the deny signify negative. And when there's a positive and negative, what happens? They cancel each other. So this will make your rule work the way it should. But if you don't do the permit any at the bottom, or permit any, your access list will not function as it should. So this is a form of like a mathematical analogy. Let me use the word to describe access list. So proceeding with our configuration. So knowing what we know and what we want to achieve right now, I want to deny PC2 from pinging PC7. So to configure the extended access list, use the keyword access list. I'm going to specify a number range from 100 to 199. So I want to use 166. Right? The moment I use this, Cisco understand that this is an extended access list, and it will give me the options of what I want to do. So access list 166, I want to what? Deny. If I use the question mark, you would see, unlike the standard access list where I had just three options, I have about 7 or 8 options here, what I could do. So I have a form of granular control. So I want to deny IP traffic. So I'll use the IP option. Then I'm gonna select if I want to deny the host or the entire network or any. So if I do the question mark again, you see I have 3 options, just like in the standard. So I want to deny a particular host, which in this case is this PC. So I need to look for this PC's IP address, which is 1.0.0.3, host 1.0.0.3. I want to deny it. All right. So I want to deny it to a destination. Unlike the standard, I don't have the option to choose a destination, because standard operates more like filtering traffic from a particular source, but extended works filtering traffic from both source to destination. So these are the core distinction between the extended and the core access list. Right? So I'm going to select any host. I'm going to select host in this case, and I'm going to specify this guy's IP, because this is the host I want to deny. I'm going to set this guy's IP, which is 4.0.0.3. So host 4.0.0.3. Hit enter. I've denied. I need to permit any, else this access list would not work. So access list 166. Mind you, the access list ID must be consistent. 166 must be consistent. Permit IP any. Then I save. Also, if you know what you know and you were listening, you would know that with what I've done so far, I have not really done anything, because I would still be able to ping from my PC. I'm going to ping 4.0.0.3. Well, see, I'm still able to ping it. Why? Because I haven't applied the access list on the interface. So I need to apply it on the interface, and going by what we established earlier on, we agreed that when you want to configure an extended access list, you configure it closest to the source. And by closest to the source, knowing that this is the origin, which is the source, knowing that this is the destination, and having these two interfaces through which traffic could move in and out of this particular router, we know this here is closest to the source. This. So we're going to apply it on this interface here. So going into that interface gigabit 0/0 IP access group. I'm going to specify the access list ID, which is 160, as in this case here. And I'm going to specify if it's either inbound or outbound, like we did earlier on. In this case, this is in and this is out. This is in for this reference out. So this is in, this is out. So it depends. It depends on the source of the traffic, right? So we know this is the in. So it is inward. So we're gonna do in there. Don't save. And now that we've done this, we should be able to deny that ping. See, unreachable. It can no longer ping because we've just denied it. Whereas every other device on the network can still ping themselves if they want to. Ping 4.0.0.3 from PC0, and you will see I am able to ping because I denied only that host. Alright? So this is basically how access list operates. We must understand first the inflow of traffic. Is it inbound or outbound? We must also understand where the source is and where the destination is. And we must also understand what we want to deny. Is it the entire IP? Is it a host? Is it a subnet or network? We must understand what we want to deny or permit. Then finally, for granular control, like in extended, we want to determine the type of protocol we want to deny. If it's an IP protocol, if it is a ICMP protocol, for example, ARP, if it is a routing protocol, for example, EIGRP, if it is, an encapsulation protocol like GRP, we need to know what exactly we want to deny and use the right commands to do that. All right. So the next thing I want to show you is the named access list. But before I move into the named access list, let me quickly show you something. One limitation of both the standard and extended access list is that you nearly cannot edit it. That's the better word to use. You nearly cannot edit either an extended access list or a standard access list. When you try to edit, you use the no, and when you use the no, which is the negation command for Cisco devices, what the no does is to remove that entire entry. And when you do that, you've wiped off the access list from your router. So it does not give us the granular ability to edit entries within the access list. This is what I mean. If I do show run, for example, knowing what you know, if I add a node to this command here, it will erase this access list entirely. It would not only remove this, it will erase it entirely, meaning there would be no access list on this router. Let's try it out and so you see. Let me copy that. Right? Copy and if I do show run, you see? It removed the entire access list. It no longer exists. So this is one limitation of both extended and standard access list. And the named access list takes care of this form of limitation. Although, let me put it out there that named access list is not actually a type of access list in a way, because we have the named access list as both extended and standard. So it's safe to say majorly the two types of access lists we have in Cisco networking are extended and standard. So let me show you how to configure the named access list. So for example, let me use this router here, the I1 router. Before I proceed, I like to test my connectivity. So you see, I want to ping the server 2 from PC4. So server 2's IP is 3.0.0.2. So then 3.0.0.2, and I can ping successfully. I want to deny that ping, so I go into the layer 3 connected to that AC. I configure the named access list. So to configure the named access list, you use the IE keyword, IP access list, not access list. You use IP access list, then you specify, is it either a standard or an extended? For example, if I use the question mark, you see, it gave me two options, standard or extended. So in this case, because I know I want to do the standard named access list, I'm going to use standard. Then I'll specify the word of my choice. For example, I want to use Maguire. Then I hit enter. All right. So I'm a Manchester United fan, and Maguire, it's a great player. So I use Maguire, right? Now I hit enter, and it took me a step further into the sub interface of the access list. So from here, I could either permit if I want to, or deny. So let me erase this and use the question mark so you see what I could do. So look, it provides me a more granular, regardless that this is a standard named access list. It is a bit more flexible compared to the regular named access list. So I have the options to either choose a sequence. I can do the default. I could deny, exit, no, permit, and do a remark, right? So I want to deny. For example, what do I want to deny? I want to deny this PC4. So I'm going to deny 2.0.0.4. So I'm going to deny 2.0.0. I'm going to deny host. Okay, let me show it to you. So if I do question mark, you see I have the options of either host, any, or the entire network subnet. So host 2.0.0.4. When I hit enter, then I need to permit every other traffic. Permit any. Enter. Alright. So like I mentioned earlier, the advantage the named access list has over the regular standard access list is that, for example, I could say no, permit any, and it will remove only this entry, whereas the rest of the access list commands are still on my router. If I do show run, you see, I still have the rest of the access list entries on my router. So I could remove some entry without erasing the entire access list, right? So I will do permit any again. So the access list, would work the way I want it to. Then I'll save it. Then, this access list will not give us the desired result until we apply it on the interface. Now, based on the rule, this is a standard access list, so we're going to apply it closest to the destination, which is, in this case here, this is the source network, this is the destination network. So this is closest to the destination, so we're going to apply it here. So we'll identify that interface, which is gigabit 0/2/0. Exit from this interface gigabit 0/2/0. Then we do IP access group. Then we specify the name of the access list, Maguire. Copy. This is case sensitive, so you must use it exactly the way you've written it. Maguire. Then I'm going to specify, is it inbound or outbound? In this case, I know it is outbound. All right, here, not here. So I'm going to use out, and I'm going to save. All right, so now let's try again and see if we can still ping the server from PC4. You see, unreachable. We've just denied it. That's unreachable now. So alternatively, let me show you how to configure the named extended access list from R2. I want to deny the server. This guy, I want to deny this guy from sending traffic to PC1. So, for example, PC1's IP is 1.0.0.2. So ping 1.0.0.2. And you say I can ping successfully. So let me log that traffic. So I go into the closest R3 to that, which is bound using the extended keyword. I'm going to do IP assets list, and I'm going to specify extended. If I do the question mark, I have two options, standard or extended. So I'm going to do extended. Then I choose a word of my, I use a keyword of my choice. So I'm going to use Bruno. No, Bruno is the captain of Manchester United, and I love him. So I'm going to use Bruno. If I use Bruno, and I enter. Next, I have the option to permit or deny. So if I do the question mark, you see what I can do again. I can do a whole lot of this. All right. So I'm gonna do deny. What do I want to deny? I want to deny this server 2 from pinging PC1. I want to deny 3.0.0.2. So deny IP. Okay, let me show you. If I do the question mark, you see what I can do. So again, when I did the question mark, you see the whole list of what I could do. All right. So I want to deny IP. So deny IP from what? From a particular host. I do the question mark again, you see. So I'm going to do host 3.0.0.2 from host. This host here, which is PC1 1.0.0.2. 1.0.0.2. Enter. Then I do permit IP any. And I save. All right. So if I close this and apply it on the interface, what interface will I apply it on? Obviously, I'll be applying it on the interface closest to the source. So I'll be applying it on this interface here. All right, so I'll apply it on exit from here. Interface gigabit 0/0. IP access group. The name of the access list is Bruno. So I'm going to copy it the way it is. I'm going to paste it here. Bruno. And I'm going to apply it on the inbound. Enter. Then I save. Now let's see if what we've done works. Oh, pardon me. I clicked on the browser. Okay, so let's try to ping again. And it's unreachable. All right, so this is how we configure access list. How to configure standard, extended, named access list on our network devices. So guys, if you have any questions with regards to this video, kindly reach me on my social media handles, you can send me a message on the comment section and I will be so glad to help you. All right. So thank you guys for watching. Stay tuned, subscribe, like, and share with your friends. All right. Bye.